Assalamualaikum warahmatullahi ta'ala wabarakatuh. We are from Group 6E would like to present about flow rate through a venturi meter in a pump system. Okay, for the group members, our group consists of only 4 people, which is first Muhammad Azrul Hisham bin Azmi, second is Muhammad Shahril Ikwan bin Mamat, third is Amirul Yazid bin Shafi'i, for the last one is Nur Ikmal Hisham bin Abdul Halim.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ikmal Hisham bin Abdul Halim. My matrix number is AA181231. I will discuss about the additional theory. So the first thing is what is a venturi meter that we are discussing. A venturi meter is a device used for measuring the rate of flow of a fluid throughout a pipe, and it is also used to increase the velocity of any type of fluid in a pipe at any particular point. So to make it simple, when a fluid moving through a small crosses section in the venturi meter, the pressure in fluid drops suddenly, leading to the increase in velocity of the flow. So, for example, if the fluid is in a high pressure and low velocity, at a particular point, it is converted into a low pressure and high velocity, that is the job of venturimeter, which is increases the velocity of a fluid. In a venturimeter, the principle applied is the Bernoulli principle. So next, I will explain throughout the equation of Bernoulli principle that will be used in the venturimeter. Alright, this is the continuation from the additional theory. As we can see here, this is the equation that were used in the venturimeter that were applied from the Bernoulli's principle. So as you can see here, this is the pressure 1 over Y, which represent rho G plus V2 V1 to the power of 2 over 2G plus Z1, and also the same one, but it's the P2, V2 and Z2. So to derive the formula, first we use the continuity equation, which is Q equal to A1 V1 equals to A2 V2. As we can see here, A1, yes. So we want to find the velocity. We let alone the V1, and we got V1 equal to A2 V2 over A1. So in the formula, we set aside, and we have P1 minus P2 over Y plus Z1 minus Z2 equal to V2 minus V1 over 2G. So we use this and apply it here by differentiate the V1, and we get the second equation, which is this is the second equation. So next, we trying to find the velocity, right? So we only have one unknown for velocity, which is the V2, because we have differentiate the V1 and we let alone a V2. So here is the continuity of the second equation, that is the third equation. Next, from the theoretical equation for the theoretical flow rate, we can see that theoretical flow rate equal to A2 V2 equal to A2 over this formula, and we get the fourth equation. So as we can see here, this particular equation can be changed into a difference into a delta H. because this particular equation represents the difference in piezometric head. So it is the same as delta H. So we change this equation into delta H right here. So as we proceed, we will have the sixth equation, which shows like this. Then when we have the final equation, as we all know, this is for the theoretical, and as we all know, the actual flow rate, which is Q actual, is differ than the theoretical flow rate. So we can change this into a ratio because it represents the discharge because the ratio represents the discharge coefficient which is CD. So this is the ratio that we have. From the formula, we can change it into a ratio, which is the discharge coefficient equal to flow rate actual over flow rate theoretically. Next, the objective. So there are 4 objectives in this experiment. The first one, to understand the effect of decrease in area on the velocity and pressure of the flowing fluid. Next one, to understand the relationship between velocity and pressure of flowing fluid. The third one is to determine the meter coefficient for venturi meter. And the last one is to calculate the flow rate and the discharge coefficient at different head pressure.
Alright. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Azrul Hisham bin Azmi. I would like to present about the procedures of this experiment. First thing first, make sure that air purge valve on the upper manifold is tightly closed. Second, set both apparatus flow control and bench supply valve to approximately 1/3 their fully open position. Third, start recording time using a stopwatch at the moment we open the flow control valve. Water started to flow in the inner tank. When the meter indicates 5 liter water volume, stop timing and turn off flow control valve. Fourth, release air purge valve to allow water to rise up the manometer tubes and form the hydraulic grade line HGL. Fifth, 5 runs will be done by changing flow rate. Also, measure H1, which is head of water in manometer tube A inlet and H2 in manometer tube D throat. Vary flow rate so that H1 minus H2 goes from 60 to 230 mm. For the sake, full flow is obtained at run 5. At this stage, the difference between the venturi inlet A and throat D is 230 mm. For the 7, record all the data into the table. For the last one, compute all calculations. The improvement can be done by always monitoring the condition of the venturimeter and can be maintained regularly to avoid error while taking the value of data. Make sure in the pump system must be clean from any of impurities such as a dust to avoid wrong or error during experiment. Student must be alert to the digital pressure display when taking the data to avoid some errors and to get the accurate value. Objectives were achieved but get some errors were encountered during the experiment and thus affected the results. I think that's all from us. Thank you, madam, for hearing me. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
So this is the result of the experiment venturi meter. There are 4 points that we study: A, B, C and D. There are 5 runs for each point. The next table shows velocity at point A and point D by using difference height A and D on the manometer. From this result, we can calculate the fluid flow rate at point A and point D.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Yazid bin Shafi'i, and now I will explain about the observations for the venturimeter experiment. Okay, for the first point, when the flow at maximum capacity by opening the regulating valve, the readings of piezometers dropped and the maximum capacity was obtained when the lowest reading was 1 centimeters. That is for the first point. For the second point, when the flow at minimum capacity, the reading in piezometers increase. And for the third point and the last point, the value of volumetric flow rate being affected by the pump speed.
So next, we move to the calculation. Given area A equal to 531 meter square, area D 201 meter square. As we know, QA equal to QD. So from the formula Q equal to AV, VA multiply AA equal to VD multiply AD. We move AA from the left to the right. So VD equal to VA multiply AA over AD. We put the value area A and area D in the formula. So we got VD equal to 2.64 VA. By using the Bernoulli, ZA plus PA over Y plus VA square over 2G equal to ZD plus PD over Y plus VD square over 2G plus H. Since ZA equal to ZD, H equal to VA square over 2G minus VD square over 2G. So from here, we simplify the formula. We got HA minus HD equal to VA square minus VD square over 2G. We put the value of VD 2.64 VA into the formula. So HA minus HD equal to 0.304 VA square. For the run 1, we are using the same formula. HA minus HD equal to 0.304 VA square. So HA minus HD, we got from the table 0.066 equal to 0.304 VA square. So we got VA equal to 0.466. VD, we put the value of VA into the formula of VD. So VD equal to 2.64 multiply 0.446. So VD equal to 1.21. To find the fluid flow rate, Q equal to AV. At the point A, we got fluid flow rate 531 multiply 0.466 equal to 244.26 meter cubic over second. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Yazid bin Shafi'i, and now I will explain about the discussion for the venturimeter experiment. For the first graph, we can see that there are measured flow against experiment run. In the x-axis, we can see the experiment run for until round 1 until round 5. And at the y-axis we can see the measured flow. For the second graph, it is a HA minus HD value against calculated flow. In the x-axis we can see the calculated flow, and at the y-axis we can see the HA minus HD. Based on the graph 1, the value of the measured flow increased after each run. It shows that the flow keep increase after each run of the experiment. The average value of the discharge coefficient is equal to 1.03, which is beyond the recommended limits. This is due to the error in the processing of the experience. The percentage of error has altered from 1.76% to 10.63%. This is considerable error, cannot be ignored, thus it has influenced the results, among which the invalid value of CD. For graph 2, the graph is a linear increasing curve. It shows that the square root of the difference is directly proportional to the calculated flow. When the value of difference between HA and had increased, the value of calculated flow also increased. One of the source of error is the fluid used in this experiment is not ideal, and the stopwatch considered as the cause that lead to error. Besides that, there were discrepancies reading the pressure heads.
Okay, my name is Muhammad Azrul Hisham. For conclusion of this experiment, we can conclude that the venturi meter helped to understand measurement of discharge from a pipe and to define relationship between different properties of fluid, that is, effect of viscosity on pressure loss, variation of pressure and velocity on different cross-section. This experiment can conclude that a venturimeter can be used to determine the flow rate in the pipelines and the pressure loss that occurring in order to control the discharge fluid addition to the discharge coefficient of a venturimeter. This experiment also gave us a real understanding of how to apply both Bernoulli equation and the continuity equation, and to study the hydraulic grid line and energy line by plotting this result. The value obtained were close for both pressure value that result from its streamline shape and almost eliminated the boundary layer separation, and it can be assumed negligible. In the venturimeter, it is also has converging and diverging part that can cause some percentage of the pressure being lost. The poor maintenance of the venturimeter also can cause the irregular flow rate of the water.